Good morning, lovely 12s. Right, buddies, we're at the very end of the unit now on Trig, so I bet you are going to miss this unit terribly. I really like this unit anyway, but I hope that you'll miss this unit terribly when it's gone. But today's the best topic as well. This is pulling everything you know together. This is going to be solving trig equations using trig identities. It's also got things like disguised quadratics in, and you get to practice all of your standard equation skills. So it should be quite good anyway. So yeah, I'm excited. So let's do it. You only know these two trig identities, and actually we don't need them for every question, but that's what we know so far. Cool. Now I'll show you how these guys work. It says, It says solve for theta in the interval of 0 to 360, which is important that we know that from last lesson. The interval is very important. This equation. So I've cut off the other one for now. So that one there, we've got 2 cos squared theta minus cos theta minus 1 equals 0. Okie dokie, my folks. Now here's where it's a bit funny in that, well, actually maybe it isn't funny. I don't know. Can any of you guys figure out what to do right now? Have a think. Okay. So I hope that you did come up with it, but actually, my buddies, it looks really hard, this question, but it's not as hard as it actually does look. If I gave you a hint, if I said the answer was disguised right there in front of you, would that give anything away? That's right, it's a disguised quadratic, buddies. Now, I'm going to do it really thoroughly, and I'm going to do it really with extra steps, but you don't need the step I'm about to do. Here you go, you ready? Let's let a equal cos theta. Because that would mean then that a squared would equal cos squared theta, which means we'd be left with 2a squared minus a minus 1 equals 0, which then you can factorize. Happy days, buddies. You can skip out the entire a part if you want. I'll tell you when it comes back in. So we're looking for two numbers that times to minus 2 and add to minus 1. So those two numbers are minus 2 and 1. So this is going to be 2a squared minus 2a plus 1a minus 1 equals 0. Factorizing the first two, 2a minus 1. Factorizing the second two plus 1, a minus 1 equals 0, which means that we're left with a minus 1, 2a plus 1 equals 0. Cool beans? Now the thing is, the question wasn't actually about a, though. The question was about cos, so we're going to have to put it back in. A was equal to cos theta, don't forget. So cos theta, take 1, and 2 cos theta plus 1 equals 0. Okay. Happy days, buddies. All we did there was a disguised quadratic, which I know that you've had a good whack of practice at, so I hope that that's not too bad yet. So here we go. The question's not actually solved yet. We have to actually do a little bit more. So now that we've got this like this, we're going to actually be given two solutions here. The first solution is for when cos of theta equals 1. And the second solution will have been move the 1 to the other side, negative 1 divided by 2, negative a half. This one's for when cos of theta equals negative a half. Okay? And that, my lovelies, is nowhere near the answer either, because we've got to now consider them separately and do a separate cast for each one. Oh my gosh, these are amazing questions. So the first one's this: cos of theta equals 1, and I'm going to do it right beside cos of theta equals negative a half. Okay, so here we go. We get to practice all of our skills. For cos of theta equals 1, that's one of the extreme values. Remember how 1, minus 1, and 0 are extreme values? So in this case, actually, the graph is best. So whack a quick graph down like that, and then you just simply say to yourself, where does it equal 1? Well, 1's the max, so it equals 1 at 0 degrees, and it equals 1 again at 360 degrees, okay? So there it is right there. That's where it equals 1, yeah, at 0 and 360. So off this one, you get two answers. Theta equals 0 degrees and 360 degrees. Now there's another one, though, as well, and it's this guy here. Now, minus 1/2 is not an extreme value. It's just somewhere in the middle. Only 0, 1, and minus 1 are extreme values. So we are going to sex and the city it. Now, here's the thing. Cos of theta equals negative a half, so it's negative, not positive. Cos is positive on the two right-hand ones. The all and the c, they're both positive there, which means it's going to live here and here. So whack a stick into each quadrant, dash, 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 down, stick into this quadrant, dash, 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 up, and we actually get to that thing that I really like to, do as well, which is this. You get to just ignore the negative, and you go cos minus 1 of positive a half. Now, when you do that, I think it's 60, I'm not sure though. Shift cos of 0.5, yeah, 60, is 60 degrees. Now, if you put the negative 1 in, you would have got probably like 100 and some odd. What would you have got? Would you have got like 120? If you do shift cos of negative 0.5, you'd have got 120, which is confusing because it's actually this angle here that's given you, but we don't care about that angle. We want the little ones inside. That's why you do it always with a positive. 60, 60, get the little ones. Okay, which means from this one here, we're going to get these two answers. We're going to get theta equals, I'm going to do it in green as well. No, I'm going to do it purple. Treat yourself. Here we go. Here we go. Okay, so come around to here. The first one then is theta equals, and it's going to be 180 take 60, so 120. And the other solution is 180 plus 60, which is 240. Cool beans? So each of these two parts has made two solutions, which means that altogether, my buddies, the answers to every single question is this. What angles do it? Well, 0 degrees, 120 degrees, 240 degrees, and 360 degrees in numerical order for your examiner, because you don't want them to miss a mark on you accidentally. So happy days, buddies. That's what we have got. It's a bit fiddly and a bit faffy, but we did get there in the end, and that's how it works. So I hope that you're okay with it. It's not too well. It's a lot of work. Yeah, I'm not gonna lie. It is a lot of work. Cool. Right then, one more. Two more actually. Here we go. Solve for theta in the same interval. It's the same question. It's just part B now, and it's got sine squared of theta take 30 equals 1/2. Okay. It's a bit of a hard question again. I'm not gonna lie. So here we go. Step 1, let's write it out. Sine squared of theta take 30 equals 1/2. Now, what's the first step going to be? I can't cast it yet because it's not just sine theta equals, it's a squared. So I need it to stop being squared. So what will I do to both sides? I say it, we'll square root. So here we go. Sine of theta take 30, we're square rooting both sides, it's going to be the square root of 1/2. However, buddies, what's the one thing you got to remember when you square root both sides? That's it. It's plus and minus, which is going to make this question way trickier. Cool? So here's what we've got. We're going to get sine of theta take 30 equaling either, and the square root of 1 is 1, the square root of 2 is root 2. It's either going to be plus or minus 1 over root 2. Now we're going to have to treat those as separate, okay? So the first one that we're going to treat is sine of theta take 30 equaling 1 over root 2. That's going to be the first one that we deal with. And the second one that we deal with is this. Sine of theta take 30 equals negative 1 over root 2. Okay, but in both instances, it's ready to be casted now, so there is at least no factorizing in this one. It's ready for casting, so let's do it. Not an extreme value, that's why we're going to use cast. Sex and the city. Okay, in the first instance, what we've got here is positive, so it's going to be A and S, because that's where sine's positive. Whack a stick into each one, drop, 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 drop. Stick into here, drop, 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 drop. And we'll go sine minus 1 over root 2. I think it's 45 degrees. Shift sine 1 divided by the square root of 2. Square root of 2 is 45 degrees. Yeah, 45 degrees. Now, even if it was negative, I'd still have put positive in because I want a small acute angle, so I can put them in like that. Which means off this first one, we get to combine our skills from last week. It means that it's not theta that equals 45 degrees, but theta take 30 is going to equal 45 degrees. Cool? And similarly, it's not theta that's going to equal 180 take 45, 135, but it's theta take 30 that's going to equal 135 degrees. Cool, mathematical implication signs. And here we go. That means then that theta is 75 degrees for the first one. And similarly here, we're going to get theta equals 165 degrees. Both of them within the range, because we got to go between 0 and 360. And the period is 360 degrees. So if you added or took 360 off each of these, they'd both definitely fall out of the range. So that's it. That's that one finished. Okay, cool beans. Again, here we go. And I'm going to cut to some chases here. Let's do it. Now here we go. Sex and the city. Sex and the city. And here we go. This time it's negative. Sign is positive here and here. That means sign's negative here and here. Cool? Sticks in. And then here. Up there like that as well. Now, I'm going to do, it's already written over here, okay? I'm going to do sine minus 1, but I'm not going to do the negative 1/2. I'm going to do this again for this one, okay? So we're going to borrow that calculation. I wanted it to be the acute angle, so I wouldn't have put in negative 1 over root 2. I'd have put in positive anyway. So I'm going to borrow that. That means that's 45 and that's 45. Cool? Which means off this one, it's the same as the other one. It's not theta that's going to equal 180 plus 45, but theta take 30 that's going to equal 180 plus 45, which is 225. And it's not theta that, it's going to be theta take 30 here, that's going to equal 360 less 45, which is 315, I think, 45. Yeah, 315, that's it. Cool, mathematical implication signs, here we go. Add 30 onto each one. theta equals 255. Theta equals 255 degrees. And on this one here, theta equals 345 degrees, both inside of the range. If I took 360, added 360, I'd be out of the range. There's no period problems there either, which means every single answer then, guys, is this. Well, here they are. Theta is 75. 165, 255, and 345. Numerical order for the ease of your examiner. Okay, and here we go. Last one, buddies. This is the hardest one, but it's not going to be too bad. I think that you guys are going to be pretty ace at it. It is going to use potentially an identity, but it's not as bad maybe as the ones that you've done previously. So if we check it out, here we go. It says find the values of x. Oh, it even gives us a wonky range. Of course it does. So minus 180 to 180. And satisfying the equation, this equation here. Code that one. Okay. Now, the trouble with this, though, if you have a good look at it, can you identify what the problem is? If you have just a little think, cos squared, sine, and sine squared. What is the problem with this? Why is it not simple to solve? Well, if you said it's not simple to solve because there's two trig ratios and not just one, that's exactly right. It's really hard to solve because there's two trig ratios and not one. So in other words, I would like there to not be coses, or I'd like there to not be sines. Now have a really good look at this equation again and say to yourself, what one would it be better to get rid of, sine or cos? Well, cos, definitely. It's definitely better to get rid of cos and to have only sines. And here's why, buddies. It's this majestic bad boy there. You're not going to be able to get rid of a sine of x because our two formulas that we have are this one here, which is used for squares, and this one here, which is used only when sines and coses are times or divided. And that's not the scenario that we are in. It's not like a division. It's just... yeah, it's only just squares we're working with, so we're going to want to use the second one here. Cool beans? So let's do it. To start off with, I'm going to rewrite it. 2 cos squared x plus 9 sine x equals 3 sine squared x. Okay, if you think you know what to do, pause the video, go, and solve it all. If you don't know, here we go. What I'm going to do is I'm going to get rid of the coses. So let's do it. Let's get rid of all the coses, my buddies. And what I'm going to do is I'm going to swap out the cos squared for a 1 take sine squared using the identity here, the Pythagorean identity that I've highlighted in blue. So if sine squared plus cos squared is 1, it means that cos squared is 1 take sine squared. So here we go. 2, open bracket, 1 take sine squared x plus 9 sine x equals 3 sine squared x. Cool. So 2, take 2 sine squared x plus 9 sine x equals 3 sine squared x. Right, what on earth are we going to do now? What should we do? We have squareds, we have singular signs, and we've got numbers all together. What does it look like? What is it disguised as for you? Oh, that's right, it's a disguised quadratic. So it's going to be a quadratic because there's squareds and not squareds. It doesn't matter that the variable isn't x, that it's sine x. It just means it's disguised. I'm going to pop everything to the right because I want the lead term to be positive. So here we go. 0 equals 3 sine squared plus 2 sine squared is 5 sine squared x. Then we're going to get minus sine x, 9 sine x I should say, 9 sine x, and then we're going to get minus 2. Cool beans? Right, it is a disguised quadratic, but I'm going to... No, I am going to do it properly. You can skip this step I'm about to do, okay? I'm going to let a equal sine x, which means that a squared is sine squared x. A squared is sine squared x. That, what I just did in red, is absolutely skippable if you can factorize it without substituting in. And I'm looking for two numbers that times to make minus 10, but add to make minus 9, just doing really normal factorizing there, harder but normal factorizing. The two numbers then are going to be minus 10 and 1. So here we go. This is going to be 0 equals 5a squared minus 10a plus 1a minus 2. And that's what we're going to get. 0 equals 5a minus 2. And this has got nothing in common, so 1a minus 2. 0 equals 5a plus 1 and a minus 2. And there we have it. Back into what we need, which are sines. 0 equals 5 sine, was it x? Yes, it is. 5 sine x. That's exciting. Something just popped. Look at that. That's cool, isn't it? Something just jumped through my box there. That's exciting. Okay, bring to front. Get back there. Get back in the box. Okay. 5, sorry about that. 5 sine x plus 1. And then this is sine x minus 2. So our two solutions that we got then are going to be these two here. It's going to be sine of x equaling negative 1/5, I believe, and the other one is going to be sine of x equaling 2. Now there is something of note here. Can you see the sine of x equals 2, 1? What do you notice about that straight away? Well, can sine of x equal 2? No, actually, because as big as sine gets is 1, right? Sine of x can only equal 1, which means this is too big. Try it in your calculator. Go shift sine of 2 in your calculator. And what's it say? That's right, math error. That means this one's not a solution, which is cool. We only have to work with 1 then. So let's do the solution for this guy then. Let's get the actual angles. So we're going to be left with, so we're going to do this one. Sine of x equals negative 1/5. We're going to solve it. Okay, cast. Let's do it. Sex and the City. It is negative, which means negative, sine's positive in the top two, so negative in the bottom two. Pop your sticks into each one, dash, 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 dash. Pop your stick into here, dash, 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 dash. And what I'll put in my calculator is sine minus 1 of positive 1/5, because I want an acute angle, not like an obtuse angle or a negative angle, none of that rubbish. Just this, just positive 1/5, please. 0.2 equals 11.5 degrees. 11.5 degrees. So that's 11.5 and that's 11.5. Oh, I can smell the end of this question, my lovelies. We're nearly there. Which means, as our final answers, buddies, here's what they're going to be. The first one is just going to be 180 all the way around to here. So it's 180 plus the 11.5, 191.5 degrees. And our second answer is going to be, 360. Take 11.5, and actually, because I've just spotted something, I'm going to put it underneath instead. Okay, x equals that, and the other one is x equals 348.5. Okay, this question had another trick up its sleeve that I didn't even spot. There was an extra trick up its sleeve. Remember how it said that the period was between minus 180 and 180, or the range is between minus 180 and 180? Are either of these two even in the range? No, it's a debacle. They're both too big. 180 is the max. So we have to actually faff with the period as well. Okay, at least there's no number touching the x. So the period is not going to be adjusted. What's the normal period of sine? Well, 360. So as they're both too big, I'm going to pop a 360 off each of them. So 348.5 take 360, just because it was already in my calculator, is minus 11.5 degrees. Okay, minusing another 360 would go too small. 191.5 take 360 is minus 168.5. 168.5. Okay, now that we've done that, we've got one period back on each of them. The numbers that are actually in the range, because the range went from minus 180 to 180, are these two. So that and that are your final answer. And these guys here, whilst they were very useful, they're not part of our answer, but they were useful, so they're not wrong or anything. They're just not part of our answer, which means our final answer to this whole question then, buddies, woohoo, is here we go, in order. Minus 11.5 degrees and minus 168.5 degrees. After I just said in order, and I've got the smaller one second, but that's okay though. So that's it, final answer, no problem, hard question, and we have crushed it. So yeah, good work on that, buddies. It's a tricky topic, I know, all of Trig's a tricky topic. Next lesson I'm certainly going to give you a revision, so that's what we'll do. Make sure you really ace at it, and that's that. So yeah, right now, I want you to try these guys here. So page 221, question 2 to 9, and to do a mix of them, okay? Because I'm going to just next time to seek out hard ones only for us to do for a whole hour. But do a nice mix of them from question 2 to 9 on page 221. And the final thing to watch out for is on questions like this, watch them, they're trick questions. Sometimes what you'll find is that you're going to have, it's like a sine squared on one side and a sine on the other. People's inclination, quite like understandably, is to like scratch out one of the squares with one of the sines. Now the thing is, you never ever can do that, and the reason why is whenever you cancel a variable, not a constant number, you can always cancel a 2 or a 4 or whatever, but if ever you cancel a variable, which is what sine of x is, you lose a solution. So this one here would actually produce two solutions, sine of x equals 0 and sine of x equals 1/2. So just be aware, I think it's question 3 that will try to catch you out with that, so just don't be caught out with it. Cool beans, buddies? Right, well that's it from me then. That is the end of our lesson, and I hope it's all good. Revision lesson next lesson, and that's it from me. See you next time. Bye, buddies!